Well, welcome everyone to our November Tech Dive session. Today we will be exploring how the Barbara platform helps you deploy edge AI use cases with ease, along with a look at our latest product updates. My name is Miriam Zabaleta, Head of Marketing at Barbara, and joining me today is Enrique Ramirez, our Senior Solution Architect, who will be leading today's Tech Deep Dive. We want this session to be as dynamic as possible. Please use the chat to share your questions at any time. We will collect them throughout the session and answer them all at the end of the presentation. After this session, we will kindly ask you to complete a short questionnaire to help us keep improving these technical sessions. And of course, we will be sharing the recording and the slides with you afterwards. So welcome to everyone. We've just been waiting for people to join us, but I think it's time to start. So the floor is yours, Enrique. Welcome.
Thank you, Miriam. Thank you very much. Thank you for all of you for attending to today's session. Okay, as every month, what we are going to do is having an overview of the platform. We are going to focus on a couple of use cases that we can deploy in the Barbara platform. One is related to OEE calculation in an industrial machine. Another one is more related to MLOps. We are going to deploy an AI model to calculate production in a solar plant environment. So apart from that, we will also have an overview of the functionalities of the platform. So today it's going to be a session mainly practical. I'm going to show how to do everything using the platform. That's all from my side. Let's start. I will start just sharing my screen. Just indicate in case you have any question, as Miriam said, please write your question in the chat and we will ask them. Okay, so I will start. I think, Miriam, I think you have to grant me. Okay, now it is to share the screen. Thank you so much. So I suppose you should be seeing my screen right now. Is it?
Yes.
Okay. So this is the presentation we're going to follow today, okay? In which the first thing is the agenda for today, okay? We are going to speak a little bit at the beginning about the edge AI, then we will see the studies, the case studies we mentioned before, and then we will have the overview of the platform. All the session will take more or less 1 hour and a half. So let's start directly with the first section, just explaining or detailing why edge AI, okay? So the edge AI or the edge computing is a new technology to run and manage application and AI model directly on hardware or devices distributed in our customer premises. Okay, they can be spread all over the world. So the platform is what we call an edge orchestration tool. We can use the platform to manage the devices that are located all over the world, they're spread all over the world, controlling them, configuring them, and also deploying AI models and application in those devices. Okay, we can do all of these things remotely. Okay, so this is what we call the edge AI as opposition to what we used to have with what the cloud. Okay, we used to run the AI models in the cloud, and now this proposal is to put all these algorithms, all this AI model in premises, okay, near where the data is being originated. Okay, so what are the keys from moving from the cloud to the edge? Okay, we can speak about different things that make our user to move their processes from the cloud to the edge. The first key we should mention is the cost, okay? The cost when we are using cloud AI is not predictable, okay? You pay depending on the resources you use on the cloud, okay? So it means that when you are having some use cases like computer vision or some other use cases like UNS where you have a great amount of data that is moving from the premises to the cloud, the bill can be quite big, okay? That is something that does not happen in the edge AI, okay? When you're using edge computing, to run your AI model or to implement your use cases, the costs are fixed and you have less operational expenses. Okay, so of course, it's one of the main keys that make our user to move from one side to the other. The second one is, of course, the security. Okay, and this is very related to the privacy. When you are sending your data to the cloud, it makes everything more risky and also less private. Okay, because obviously you are exposing your data outside your internal resources. Okay, so most of the attacks that have been received in the last years. I have here the exact figure. The 61% of the cloud services received attack during 2024. Okay, so it makes all the service running in the cloud to be the main target of cyber attack. Okay, and also well, you need to take agreement because you are moving your data to the public world. Okay, the data is leaving your facilities. Okay, so at the other hand, when you are using Edge AI, you have a private attack surface. It's quite easier to make everything safer because the data does not leave your premises. Okay, and also because of the same reason, it is also more difficult to lose the privacy. Okay, so that is other two keys, security and privacy. Finally, we have another reason when using Edge AI instead of Cloud AI is because of the solution related to Edge AI as Barbara tend to be more user friendly. Okay, so especially when we are talking about OT people, okay, that normally are not really very related to IT solution, which are more complex. So this kind of edge orchestration tool like Barbara are quite more easy to use for OT people than the others. Okay, I would add one more key here that is not mentioned. That is the latency. Okay, what you need that the result of the processing you are making with your algorithm to be really quick. Okay, you cannot send the data to the cloud because the necessary time to move the data to the cloud, be processed there, or come back is quite higher. So in that case, if you need quick responses from your algorithm, you need to run your algorithm on the edge. Okay, so it should be the fifth key from moving your algorithm from the cloud to the edge. Okay. Okay, this is the Barbara HAI ecosystem. Okay, let's explain a little bit about it because at the end, as I mentioned, the Barbara platform is a tool, an orchestration tool that allows you to manage all these devices and allows you to deploy applications to create different use cases. But at the end, our customer doesn't need a platform. They obviously what they need are solutions. Okay, so that is why this ecosystem allows Barbara to provide a end-to-end solution to the customer. Okay, so we have always the customer is in the middle. Okay, with their needs. Okay, then we have integrator and consultant that allow us to reach the customer via their services. Okay, and they are the ones which normally use the Barbara platform to integrate the use cases that our customer needs. Okay, and they rely not only in the Barbara platform but also in the applications, AI models, development, data acquisition, and complementary platform that other partners from Barbara add to the solution. Okay, we have all of them available in the Barbara marketplace. Okay, so we will see later that we have the marketplace that is another part of the platform. So you can choose AI model, you can choose data acquisition tool, you can choose other connected to other platform, and this way you can integrate all these services together easily for having a complete use case for your customers. Okay, so this is what we call the Barbara AI ecosystem, based on partnership, based on integrator and consultant, and also these applications are available in the marketplace. Okay, well, I think this is a good overview, a good architecture, a good way of explaining the architecture of the Barbara platform. Okay, so again, here we have what we call an edge node. Okay, an edge node is basically an industrial PC or a virtual machine that is deployed on our customer facilities, normally near where the data is being generated. Okay, so we put this equipment there. We are hardware agnostic. We will see it later. So that means that we can use different hardware to create this edge node. Okay. The only requirement we have is the edge node should run this Barbara core. And Barbara core is basically an operating system developed internally in Barbara. It is designed thinking about cybersecurity. We will see in some minute all the functionality related to cybersecurity that this OS implements. Okay, but basically when we install this OS in the hardware, we have here what we call a Barbara edge node. This edge node automatically connect to our API, and about the API we have panel, and then we have marketplace. Okay, panel is the interface that we normally use to control these devices, and marketplace is an application hub that contains over 150 different applications ready to be deployed in the edge node here. As you can see, we live in what we call the orchestration plane. Okay, that means that Barbara panel lives in this area. Okay, and then we have the solution plane. Here is where we deploy the application from the marketplace. We connect them to create these data flows. So at the end, the data is in this side. The solution, the Barbara solution, lives at this side, so we don't see your data. Okay, we will also see it later in the demo. But basically, this is the way of working. So using panel to select marketplace application, deploying in the edge node, and then creating different use case. The platform itself can be installed either as a SaaS on cloud, okay, and also on our customer premises if they want to have a private instance for the whole platform. Okay, so this is also possible to be done. Today we are going to use the cloud version, but we have other customers that they have their own instance of the platform, and so that way everything is inside the facilities. Okay, so well, we have seen this diagram. And well, this is another way of seeing more or less the same. Here we have an edge node, okay. Inside the edge node, we have this Barbara core, which is the OS, or the OS that is running inside the hardware, and it is communicating with panel. And as you can see, using panel, we can install and deploy different kind of applications. So check that we have the possibility to install marketplace application and models, as we mentioned before. But not only that, we can also deploy user application. I mean, applications that are developed internally by our user, and also AI models that have been trained internally by our customers. Okay, so we are not limited to use application from marketplace. We can also deploy application and AI model that belong to our customers. Okay, so this is the way of working. When we have deployed the application here, we can have remote access to the user solution. Okay, using a VPN. Okay, and also locally in case you are in the same LAN, in the same network where this edge node has been installed. Okay, so we have both options. Then we will have also the remote access to the orchestration platform using panel. Okay, so this is another diagram that shows everything. So let's start. I think that is a good idea to start to see the platform in action before going deeper in the main functionality. Just see a couple of examples. Okay, so what are we going to see? We are going to start seeing OEE and then MLOps. But before going there, to mention that the Barbara platform is a really horizontal platform. Okay, we can deploy any kind of use case available, but we mainly focus on some use cases that are quite popular nowadays, and we can provide end-to-end solution to cover these topics. Okay, so as you can see, we have solution to work with data operation and unified namespaces. Okay, we can also cover predictive analytic use cases, computer vision. This is one of the hot topics that we have nowadays. then also software-defined automation, okay, like virtual PLCs and this kind of thing that can be deployed as a software and create a virtual PLC using an edge node in Barbara. And finally, cybersecurity, okay? We can also deploy cybersecurity solutions in our edge node. Solution that before were or used to be hardware, okay, devices that make all this functionality. Now they have been converted into software, so we can deploy the software and to run them in a Barbara edge node to offer the same functionality in the cybersecurity area, okay? So let's move to our first case, okay, first use case. We have what we call an OEE calculation, okay? And at the end, what we will do is simulate. We have a basic machine, okay? We are going to use for that an application that we have in the marketplace that is called Industrial Simulator, okay? Because it allows to simulate any machine, okay? Basically declaring the parameter we are going to publish in an MQTT broker, okay? So this way we will have a data flow, an initial data flow that is simulating the data will be received from a CNC machine, okay? So using this data, we are going to publish everything in an MQTT broker, okay? Let's move to this diagram because everything is showing better. We have the industrial data simulators here. It will be publishing a data flow in this broker. Then we will have a node-RED that basically will read the information from the broker and write again the information from the broker. Here is where we will make all the calculation for OEE, okay? So I will read the parameter from here, I will calculate OEE parameter, and I will publish back here, okay? Then we will have an influx real-time series database to store everything locally. This is an ingestor that helps me to move the information from the broker to the database. And finally, I will have a Grafana that allows me to deploy a dashboard for visualizing the OEE on real time, okay? For those who doesn't know what is OEE, it is defined as the overall equipment effectiveness, okay? So basically we have to calculate the availability, performance, and quality of the equipment, okay? And once we have these three parameters, which goes from 0 to 1, okay, it is just a parameter that goes from 0 to 1, okay, we multiply all of them, and the number resulting is what we call the OEE. The availability is the time that the application is working normally versus the time that it's not working, okay? So it is a way of measuring how many times is the equipment available. The performance is a way to calculate how quick is working the machine, okay? We have calculated the time necessary to create a product, okay? So in case you are creating products more quickly, the performance will be better. If you are creating products more slowly, the performance will be lower. Okay, so that is the way we can calculate that. And finally, we have the quality. Okay, the quality is calculating how many products have been well done versus how many of them have any problem in the manufacturing process. Okay, so this way we calculate these three parameters using node-RED. Finally, we will multiply them, and then we will have the OEE calculation. Okay, we will push all this data again to the MQTT broker. Then they will be moved to the Influx database, and finally we will have all these visualized in the Grafana. Okay, so this is what we're going to deploy. Okay, in the Barbara platform, and what I'm going to do now is moving to the platform. Okay, we will select an edge node that we have in the platform available for us, and then I will start deploying this application. All these applications that I'm going to use are available in our marketplace. We will see it later in more detail, but just let's start moving to panel, okay, where we have everything necessary to create this use case. So now what I will do is just selecting every line here in panel. It's a different equipment, okay? So these are edge nodes that are in different parts of the world, okay? So I can select any one of the equipment and I can start working with them. For example, I have this one available to create this use case. Okay, so we have here all the information about the equipment. We'll see it later in more detail. Here I have the applications and model part where I can start deploying everything. Okay, so I will start just deploying the first thing, okay, which is the MQTT broker, which acts normally as the communication backbone of the every use case. So it allows me to decouple the data inputs from the data consumer. Okay, so it is very useful to do it this way because just with a single broker, I can add more machines in parallel, okay, publishing all the information. So at the end, I can increase and scale the use case just using this piece, which is the MQTT broker, very popular and common today. Okay, so I will deploy the broker. I will deploy then the industrial data simulator, and then we will connect to the broker to visualize the information we are receiving from this industrial data simulator. Okay, so let's go back here, and I will just add the MQTT broker. Okay, so I will add an application, which is the broker. Okay, and here I can select the version, and then this wizard allows me to configure everything related to this application. I will use just the default values for the sake of simplicity. So I will just send this application to the edge node, and I will see that I have now a card here indicating that I have a new application with each broker, the version, the status. I can stop and start the service. I can update the version whenever there's a new one available, and I can configure everything again if necessary. Okay. At the end here, I can see the logs of this application that are available on real time. Okay. So this way I can see that the broker is ready, and now I just need to start deploying the industrial data simulator. Okay. The industrial data simulator is a really easy application. It's very easy to use. We just need to configure it to communicate with our broker. So that is why I won't change this parameter because I will use the default one as before. And here I have to indicate what kind of information I will publish in the MQTT broker. Okay, so it is really easy. I have here a configuration previously saved. Okay, and it is here. Okay, it is also very comfortable in Barbara. You can create different template covering different parameters and application. Then you just need to select a load. Okay, this is very convenient. So now what I am saying is, okay, you are going to use the information about the CNC machine called CNC01. It is everything is included in this file. Okay, it is a CSV file. Okay, that includes all the data we are going to be publishing every 5 seconds. Okay, and we will call this data stream in the MQTT broker. We will call it CNC01. Okay, so I can send this application. Okay, it will install. Okay, in the meantime, I will connect to this broker to visualize what is happening here. Okay, so in order to connect to this broker, I have to check that the IP of my edge node, we will see also later with more detail, but I can use this VPN that is available for this edge node. Okay, this is the IP of this equipment. Okay, so now if I want to connect to this broker, I just need to use a MQTT Explorer application that we have here. Okay, so it's an MQTT Explorer. I just need to indicate here the IP of this machine, and then I can check that the user is this one, the password is this one. I also have the port here. Okay, so this way I can configure everything to connect our MQTT broker. Okay, so I have connected here, but check that I'm not seeing anything. There is no information being published in this broker. Why? Because if I check the logs, this industrial data simulator says we have an error opening this file. It basically cannot find the file. Why not? Because we haven't uploaded the file, in fact. Okay, so this industrial data simulator offer me a file browser in this port, okay, to upload the file. Okay, so that is what I will do now. I can open a new tab, and using the same IP I used before. This is the IP of the VPN of the dash node and the port 8888 that we have just seen. I can enter in this file browser. So now I can basically indicate here that I want to use a file, okay, and the file is this one, okay? So I have uploaded the file to my edge node remotely, okay? So now, if I go back to panel and I check the logs, I can see that it's already sending data. Okay, so it has finally found the file and it is working now. If I go back to my broker, I can see that now I have some messages here. Okay, and these are the messages that are being published by the industrial data simulator. It basically shows the information about the machine called CNC01. Okay, it is very small, but I don't know if you can see it properly or not, but it's CNC01. And then I have information about the accumulated stop, Alan code, cycle time, energy consumption, I don't know, number of pieces done, pieces that are okay, pieces that are not okay. So all the information that we need to calculate the OEE, okay? So that is fine. We have here these parameters, okay? I'm going to minimize this, and then I will continue with the other part of the use case. Okay, we were here, sorry. So we have deployed the industrial data simulator, the MQTT broker. Now I will deploy the Node-RED, okay? So let's do that. I will just add a new application, which is a Node-RED, okay? And then I can configure it again using this wizard. I am not going to take anything, okay? This is the port where Node-RED will be published, okay? And finally here, I can add the flow to be created when the Node-RED is installed, okay, directly. So this way I do not have to open the application and start creating my flow. I can just use one, okay? So I have one flow here. It is a flow exported in JSON format, so I can copy it here, okay? It is just the necessary flow that has been exported with this label in JSON format, okay? So I just need to copy it here and send the application. Once I do that, I will see that the Node-RED application is building and installing, and now I can enter here, okay? Again, I just need to open a new tab using the IP. Okay, I need to copy the IP again. Okay, so I need to open the IP and then the port 1880. Okay, so this way I can check that I can enter in the Node-RED application remotely. Okay, and I will see that here I have this OEE calculator for CNC. So I can see that I have a block that is reading information from the MQTT broker, then it's parsing the JSON format it received. Then we have here the calculation, okay? And it is just basically Python code, but we can see how we calculate the availability depending on the status that the machine is reporting. We calculate the performance at the relationship between the ideal cycle time and the normal cycle time. Then we calculate the quality at the number of OK pieces by the total number of pieces, okay? And finally, we calculate the OEE, like the multiplication of all of them, okay? This is a very basic way of calculating an OEE, where more machines are involved in a production line. There are better ways to do that, okay, more complex way to do that, but it's very good to show how to implement the basic use case at the end, okay? So what we are doing here at the end is just creating a payload, the message that will be published again in the MQTT broker. I will just do one thing. I will check that it shows that the broker is connecting, but it cannot connect because it lacks the security parameter, the username and password that I will going to indicate here, okay? So these one are the username and password that I put in the wizard when I deployed the MQTT broker. So now, as you can see, after putting this information. It is connected. We can see here in this column how we are publishing new messages in broker, and we can also see here in the Explorer now we have a second kind of messages that include not only the previous parameters, but also the performance, the quality, the OEE, the availability. So everything is published here now again in the broker. Okay. So, well, we have one more piece in the puzzle. Okay. So let's continue with the last step. Okay, which is basically deploying the database, moving the information from here to here, and finally having the visualization dashboard very quickly. Okay, I will go back to my application. I will collapse my cards to see better. And now I will just deploy this InfluxDB database. I will deploy it just using default values. Okay, and we will have it here in some seconds. Okay, well, it has started. So now I can also open a new tab using the IP and with the port 8086. I can enter here and I can check that I can enter in this database. Again, remember the database has been deployed locally on the edge. It is not on the cloud. And now, obviously, I won't have any kind of data here, okay, because it is empty. I'm not moving anything from the broker to the database. To do that is why I need this little piece we have here, which is the ingester. Okay, so let's deploy the ingester. And in the ingester, mainly I'm going to indicate that I want to move the data from the MQTT to InfluxDB. These are the configuration necessary to connect to both services. And here is where I will indicate that I will use this one we have here, but basically I am saying search for this information in the MQTT Explorer, check that this information comes from this device display name. Okay, it's searching for this kind of messages in the broker, and then once we have it, these messages are saved in this bucket using this name. This is basically what we are going to do. So I deploy the application, and I can see after the ingestor had been installed. Okay, I can see in the logs. Okay, so it is supposed to be already moving the information. Okay, it is writing, as you can see here. Okay, we are writing already to the database. So now if I reload this view, I will see that we have a new device called CNC, okay, with all this information that has just started to arrive to our database. Okay, so last step is basically deploying the Grafana. Okay, and we will use this Grafana. I will connect the Grafana to the InfluxDB. It will be available in this port. And now here is where I can put here an already prepared dashboard and also export it in JSON format. Okay, I have one available here, this one. So I will use this. I will send this application. Okay. And after the application has been installed, I will see I can enter to the same IP using this port. And now we should have, okay, here we have all the information of this equipment. Okay, so this is the way of, this use case is quite interesting because it mixture a couple of things. It shows how to make a basic data collection, okay, just reading something from any machine, moving it locally to a MQTT broker, then moving it to a local database, real-time series database, and finally having a dashboard. But in this use case, we also use Node-RED, as you can see here, to this kind of calculation to, calculate the OEE that we have here. This is parameter. We have the actual calculation of the actual OEE. As you can see, whenever the performance goes down, as now, it is noted here. Okay, we have also the energy consumption of the machine, the speed or temperature, ARM element vibration, I don't know, different status of the machine, alarm code, everything is here, okay? So it is a good way of explaining how can we get the data from a machine, process it somehow, and then having a visualization dashboard, okay? This is the first example. So, well, I think we can move to the next use case, but in case you have any doubt, please write it in the chat and we will cover it later, okay? So let's move to this. I will close everything related to this use case to avoid confusing myself, okay? And let's move to the second use case. In this case, we will do something similar somehow, okay? But this time we are going to use, instead of calculating the OEE parameter using Node-RED, what we are going to calculate is the production in a solar plant using an AI model. Okay, so we will go one more step here. Okay, so we are going to simulate a photovoltaic plant. Okay, well, not simulate. We will use the data, the data from a weather station. Okay, so using this data from the weather station and using the location of the plant, we can calculate the production based on the solar radiation every day. Okay, so that is what we are going to do. We are going to use this machine learning model to do that. To predict the solar radiation, we will use Barbara, obviously, and we will also use third-party application. And now we have a quite, well, it has something similar to the previous case we have seen, but in this case, check we have here, this is a weather station, okay? This is the weather station that gives me all the information about the weather they have in the solar plant. We are reading all this information using an OPC UA protocol, so we can see how to use, instead of using the industrial simulator, now we are going to use a real OPC UA connector to read data from an equipment. Okay, but the behavior is the same. We read the information using OPC UA protocol, and we will publish everything in a local MQTT broker, as you can see here. Okay, then we will have a TensorFlow model that is reading the information from weather and publishing again in the broker the prediction of the solar radiation. Okay, so now what else is happening? We will have another application installed here, which is called an alert manager, and this is a really useful application that allows me to monitorize all the parameters that are being published in the broker, and I can define threshold. So every time any variable exceeds some threshold, okay, or goes below some threshold, I will receive a notification in the way I want. Okay, we can use different channels. Okay, so we will use this for receiving alarms from this service. Okay, and finally, we have also here another interesting application, which is it is titled ML Monitoring Tool. It is an application that allows me to connect to the AI model that is running locally and get all the information about how well is performing or how bad is performing this AI model. Okay, so this way I can check how many requests I am receiving, how many time I take to give an answer, to give a response to every request, how many resources are being consumed, how well is performing the AI model. So taking all this data is really necessary, and it allows me to detect, for example, when I should retrain my model or something like that. Okay, then we have the final step here. This part is exactly the same we have seen in this previous use case. We have the InfluxDB time series database, okay? We have the ingestor to move all the information about prediction and weather to this database. And then we will have a Grafana that allow me to visualize all the information locally, okay? In this case, we also have this interesting piece we have here, this Azure ingester, because what we are doing with this equipment, with this application, is reading the broker, selecting some variables, and pushing them directly to the Azure cloud. Okay, so this way we can have some other processing on the cloud, and we can send to the cloud some variables that we need or some information that had been already processed locally or pre-processed locally to be used then in the cloud. That is another possibility we have using Barbara, okay? So the good news in this case is we don't have to deploy everything step by step as we did again because it's already prepared. So let's go to this equipment where we have all these applications. Okay, it's in this equipment, and as you can see here, we have everything that has been explained here. It is already deployed here. So let's do one thing. Let's go to see the well, we have the broker, of course, but let's move to the OPC UA connector. Okay, remember this is a connector we will use to read the data from the weather station, and that is basically what we are using. Okay, we have the weather station in this URL. Okay, this is an URL from our labs, by the way, and then we can select. We can say, okay, we are going to read the information from this URL. Okay, we are going to call it the weather station. We are going to refresh it every 5 minutes, and then we will have the index, the apparent temperature, the cloud cover. So here is where we declare the variable we are reading from the weather station, okay? And in the same way, we are publishing it in this broker we can see here, okay? So all the information is being moved from the connector to the broker. Then we have this solar irradiance model, okay? This is the AI model that we have trained with that data to predict the radiance in the solar plant, okay? Check that it has been done in TensorFlow, okay? It's a TensorFlow AI model, and we have deployed it in the edge node, and here we can see the inference REST URL. Okay, so we can see here that this is the URL where I should send my request with the actual data from the weather station to receive the response. Okay, so this is basically what is doing this this AI model here. Check, we have also this metric REST URL because this is the URL where the ML monitoring tool will connect to get all the data of the performance of that model, okay? And in fact, we have here this ML monitoring tool, okay? We can see that it has been configured to connect to this URL, which in fact is the one I showed you just before, okay? So now, how can we see this data deployed by the ML monitoring tool? We can see that the ML monitoring tool is available at the port 3000. It offers a Grafana. So the only thing I need to do to check this information is copy the IP of this equipment, which is this one, okay, and opening the port 3000, I will be able to access this Grafana to check the performance metric of this AI model, okay? Again, I enter in this Grafana, and here is where I have all the information for this model, okay? There are several dashboards. We have the TFX metric, where we can see the number of requests, the latency, average latency, all the information about the input, output, site histogram. Everything is available in this graphics, okay? And then I also have the information about the server, let's say, how many resources are being consumed by the server. So all the information about the AI model that you can see on the server of this AI model, which is TFX, it is available here, and it is done by using this ML monitoring tool that you can see here, okay? Let's go back to our diagram, because we could see that we had the connector, the AI model, the ML monitoring tool, everything is publishing here in the broker. So let's see the alert manager, and let's see this part here where we can see the actual prediction. Okay, and finally we will see the Azure cloud. Okay, so in the alert manager, what we basically do is it is connected to the broker. So we just need to indicate here, okay, I want to receive notification from email. In this case, I want to enable the mail notification. I put here the recipient, okay? And then I indicate I want to receive notification whenever this telemetry data of the node exceeds some threshold. Okay, for example, I am going to receive warning if the disk is over 75%, or if it goes beyond 90%. Okay, and then I will also check or monitor the different services that are running in this edge node. So in case some of these services is going down, I will also receive a notification to alert me this way. So we can select any kind of variable, any kind of service, any kind of parameter, put the threshold here. So every time it exceeds or goes beyond this level, you will receive a notification via email, via Telegram, etc. Okay, so this is the alarm manager. And finally, we have the same we had before, the ingestor, the influx, and the Grafana. Let me show you directly the Grafana, where we will see, in order to enter this Grafana, again, I have to use the IP and the port 13,000, okay? And here, I will see that I have all the information about the weather station and also the prediction, okay? So again, I can see here, I will just increase the timing. So check that we have these peaks that basically reflect day versus night. Okay, day, night, day, night, day, night. So obviously in the night there's no production at all. So we have here all the information about the temperature, the apparent temperature, the cloud cover, direct radiation, diffuse radiation, all this information about the weather station, okay, in real time. And then here is where we have on green the global tilted radiance now, and in yellow the prediction for the next hour, as you can see. And here is where we have the error that we are making every time. Okay, so this is the way of having all the information about temperature in this solar plant. And then here is where we are calculating the next radiation for the next hours. Okay, so finally, we can, I mean, we can add as many calculations as we want this way. And let me show you the final step we had here, which was this Azure IoT Hub ingester, which is an application that mainly allows you to decide what kind of information do you want to move to the cloud. In this case, we are using the weather station information and the solar model ingester information. We are taking both variable, and in fact, both are in the, well, we are not seeing this MQTT broker. Let's connect to this broker. I think we should see something. Okay, so now we have to change this IP. Okay, we can connect. So now here we have, well, it is the notifications. This is created by the alarm manager, but not, we are not receiving any information here by the OPC UA because it is updating the information every 5 minutes, so we should wait up to 5 minutes to see something here. Okay, but anyway, what I wanted to show you that the information published here by the OPC UA broker is what we are going to move to the Azure data, to Azure cloud. Okay, so we have to indicate the Azure connection string. Okay, we got to take this token from the cloud and put it here, and to configure everything to connect the broker. And here is where we declare what kind of variable do we want to move there. So it is actually moving the information to Azure. In fact, I think we can use this Azure IoT Explorer. Okay, this is a tool by Azure that allow you to connect to, here we have, okay, sometimes, I don't know, it's failures from time to time. Okay, here we have. So we can see here we have the weather station information in the Azure cloud, and also the solar model injector. So we can select it, for example, and we can see the telemetry we are receiving here, as you can see. Okay, so we have receiving all the numbers for prediction and actual values in the cloud from the edge node. Okay, So, well, this was the second use case I wanted to show you, a way of just deploying AI models in the edge node remotely using Barbara panel. Okay. Okay, fantastic. So, well, I think we have covered the two use cases. I don't know if somebody has any question.
Hi, Enrique. We do have several questions related to the use cases. The first one is within the first one, the OEE. Newton mentions, can we have the files, the CSV file, the Grafana and Node-RED for our own demonstration to our customers, whether they can share that file of the calculation, I guess, yeah?
Yes, it is also possible
To share it?
to share it. In fact, the first use case is going to be published in our academy very soon. Okay, so it will be public. We will publish a tutorial on how to deploy all these use case. But yes, we can provide you to those who ask for. We can provide this template to be used in your demonstration.
And then we have regarding the second use case, if the TensorFlow is weather information, I guess if it's from the weather machine, real life, or is something else, is I guess whether we just collect that data
Yes.
from the web or it's just.
Yes, at the end, what we were doing was simulating this weather station, obviously, and
Okay.
we did that taking all the information from a site available in well, Open Meteor. It's a well-known service that publish all the information from all the world. Okay, so we just select the location of the solar plant, get all this information. So we created an OPC UA server that is publishing everything to be used in this use case and to use the OPC UA connector to read everything. Okay, but at the end, we could use a real weather station and read it using OPC UA. Okay, it's just real data from the weather. Okay.
Okay. So related to that, the same person is asking that is very, very interesting, this use case. So if a customer wants to understand the irradiance of the solar panel or operational efficiency of the CNC machine, will they be also looking at the machine learning dashboards and efficiency of the AI model?
No, when we speak about radiation, should look in. Let me share again my screen. Okay. So we have two different dashboards. One is this one, okay? And here is where you will have the prediction of the solar plant, okay? The same way we had before the OEE calculation, okay? And then we have this other one, which is very similar because it's the same service, it's Grafana, but this is different information, okay? So this is related to the behavior or to the performance of the AI model, okay? Let me enter again. And the other one is not related to the performance. In fact, it's the actual of the real prediction given by the AI model. Okay, so they look really similar, but they are completely different information. Okay, well, I have to log in again. But anyway, again, these are created by different services. The first, the performance is created by this application. Okay, and the final result is done by the Grafana, which is basically connecting to this InfluxDB database we can see here.
Okay. And another question right now. Can an entire use case, including all the connections between deployed applications, be templated for ease of deployment to multiple edge nodes?
Yes, obviously. That is something we will see later, okay? But one of the most powerful features about Barbara is that you can deploy all at once, okay? And I mean all at once as this user ask in two ways. The first way to pack or to deploy everything in a single click, okay? We are working in this feature to be included in the UI, okay? That is going to be moved to production, I think, before the end of the year. But the possibility to deploy what we call recipes, okay? So instead of deploying one by one, application one by one and configuring one by one, we can have a pack of application already configured all together, and then we can deploy all the thing together. Okay, that is one thing. Actually, even if it's not available in the marketplace, we can provide you some scripts, because we have available also, I didn't mention, but we have available the API access of the tool. Okay, so this is our API description. So all the functionality of Barbara panel is available also using this API. And using this API, we can provide you some script that help you to deploy the complete solution in a single click instead of deploying one by one. But this is related to creating a use case in just one step. But then we will see it later. We can also use what we call the batch command. And the batch command is a way to select all my edge nodes at once, and then, for example, install something, or configure any parameter, or playing or stopping any services or whatever in hundreds or thousands of devices in a single click. Okay, so it is also possible in both ways. Okay.
Okay. And the final one, because we keep is the use case of the edge MLOps. Suganda is very interested in knowing if is anybody at the end, the user, if the user is interested in looking at the AI model dashboards, whether that's the case.
Oh,
Who is the
yes.
persona at the customer
Yeah,
end
I
who
understand
will
now.
want to
Sorry.
look at the dashboard? That was
Sorry.
our mistake. Our
Sorry.
mistake.
Yes,
Yes.
thank you. Good question. Yes, normally the performance dashboard is more related to the data scientist, okay, not the end user. The end user just needs to know the production of the solar plant, to optimize their processes internally, and I don't know, to make their internal task to optimize the production, okay? But he doesn't care about the performance of the AI model. The performance of the AI model is something that normally is related to the data scientist and to the integrator that is normally implementing this use case. Yes.
Okay. So that's all right now for now.
Okay, fantastic. Good question. So what we will do, we will take an overview of the platform. You have seen it in action. Okay, you have seen how can we deploy different applications. So let's move and let's talk about some concrete theme. Let's go back to the presentation. So we will start speaking basically about provisioning new devices and how to provision new devices, okay? And then we will go back here to speak a little bit about cybersecurity. So well, we are speaking about provisioning new devices. I will jumping from the presentation to the platform, sorry, but it is the way. In order to provision new devices in the platform, the process is really, really simple, okay? I mentioned before that Barbara was a hardware agnostic tool, okay? That means that we can use different hardwares to create edge nodes. For example, we have here the complete list of devices that are compatible right now with our platform. Check, we have from very small and cheap devices like Raspberry Pi to the most complex and powerful industrial servers from the well-known vendors that you can see here. Okay, we can also have devices that have GPU available, like the NVIDIA Jetson Nano, Jetson Ori, some equipment by Advantech and others. And not only physical devices, check that we have here this kind of equipment that are virtual machines. Okay, so we can also create edge nodes using virtual machine. We are compatible with VMware, with KVM, and with Hyper-V. Okay, so the process to include one new machine is really simple. I think you are not seeing. Are you seeing my?
No, right now, no.
Okay.
You
Okay.
went very fast. You jumped very fast. Okay, let's do it again, yeah?
So I think much better now. Here is where you can see the devices. Okay, sorry about that. And well, I was mentioning that we have very cheap devices like the Raspberry Pi. We have the other very complex and powerful devices. Also NVIDIA Jetson and virtual machine, as you can see. Okay, so the process to provision one new device in Barbara is really simple. We just need to indicate, okay, for example, I want to include one new equipment based on this Advantech ARKey devices. The only thing I need to do is just downloading this OS, okay? installing the OS in the equipment, and after the installation have finished, I will have an ID. Okay, I will get an ID from the device in the display. With that display, I just need to go back to the node list, add a new node, put here this ID, and that's all. Okay, so it is a really simple way of working, a way of provisioning a new device, and it make it convenient when you are sending, some people that maybe are not really related to the IT world. They don't know how to configure a network. They don't know to configure or to harden the device. So they just need to install the OS, plug it on, and wait for this ID, and that's all you need to do. It's really simple. Some more things related to the provisioning system. Check, we have here what we are downloading is this OS I mentioned before, what we call this Barbara core, okay? And the Barbara core is this Barbara OS developed by us. So I mentioned that it was designed thinking about cybersecurity, and it's true. Here we can see in the presentation all the list of functionalities related to cybersecurity that this OS implement from the very beginning. That means that you don't have to take any time to protect your device, okay? You can be sure about that. So there is no root access, there is no user password access, no way to access the device remotely using OSSH, nothing at all. All the ports are closed, okay? So only authorized communication are allowed. There is no incoming communication channel. Okay, so all the communication from the device to panel are outgoing. Okay, so the device, let's say that the device pull the information instead of being received from the outside world. Then all the outgoing channels are secure. There is file system isolation, there is full data encryption, and matched identity management. Each device has their own certificate, unique certificate per device. Secure boot, trusted provisioning, TPM support, secure and synchronous update. So as you can see, when you install the OS in the equipment and you put the equipment in on premises, you don't have to take not a minute to securize it, because everything is already done. Okay, the only thing you need to do is open a set of ports that need to be available to the device to go to get the information. Always outgoing port, never incoming. Okay, and this way you will have hardened equipment and secure equipment that is ready to be used. Okay, so let's continue. Okay, we have the provisioning system, we have the cybersecurity feature. Let us speak a little bit about how deploying application and model, which is the most interesting part. Okay. And then we will see how to manage edge node. Okay. So as we saw in the use cases we deployed, we have the possibility of deploying application when we enter in any device. For example, we have entered here in this equipment, this OpenTech equipment. We have the applications and models area, and normally if there is no application running in the equipment, this is empty. Okay. So what kind of things can we deploy here? We can deploy anything that comes from our marketplace. Let me show you our marketplace, because we have been using applications from the marketplace. We have used several of them, but we have never seen the marketplace until now. So this is the marketplace. It contains over 150 different applications, and they are categorized in several sections. Okay, so as you can see, we have, let's see some of them. For example, the industrial category contains applications that allow you to read information using industrial protocol like OPC UA, Modbus, BACnet, Profinet, I don't know, IEC 104, IEC 61850, I don't know, the most common industrial protocol. So we can read the information from OPC UA, from PLCs, from SCADA, from any industrial sensor or equipment using this protocol. But we can also send this data to third-party application or to the cloud. Okay, so for example, we have here, we can see here the industrial data simulator that we use in the first use case. We have the OPC UA connector that we use in the solar plant use case, but we have also Modbus. We have connection with or integration with Aviva, Stratastor, which is one of our partners. We have here the sub-DPAP from Schneider. I don't know, ignition, integration, but also solution to send the information to the cloud. Because, for example, we used before the Azure ingestor, but we have also ingestor for Google Cloud and for AWS, different possibilities for working with industrial data. Not only that, we have also the storage solutions, okay? We have been using the InfluxDB database, which is a really good database for when you are using with time series data, with time series values. That is why we were using it. But we have plenty of different possibilities to store the information locally. Postgres, Elasticsearch, MariaDB, Redis, I don't know, a lot of different possibilities to save your information locally. We also have analytic tools, tools that allow you to process and visualize and analyze the information locally. We already use Grafana, Node-RED, but we have also Kibana, Prometheus, Kafka, Apache NiFi, Splunk, Flowfuels, I don't know, a lot of different possibilities to do this kind of analytics. Then we have, for example, communication solution like MQTT broker we use, but there is a lot of more possibilities to act as the communication backbone in the edge node. Artificial intelligence solution, okay, so you can deploy different AI model or AI tools. So, for example, we have the Jupyter Lab here. We have MLflow. We have video computer or video solution, video application to work with computer visions use cases. YOLO model from Ultralytic. We have LLM. We have, I don't know, different ways of working with this ML model. And finally, we have also the possibility to deploy virtual machine that you can see. Okay, so this is something that some of our customers need because in the industrial world, sometimes we have to integrate ourselves with really old equipment, with legacy equipment. So sometimes our customer demands us to run this kind of legacy OS because they need to run their drivers and this kind of thing, all drivers. So we can also deploy any virtual machine on top of an edge node, okay? So, well, this is everything related to the marketplace. As you can see, it's like a big Lego box where you can take your pieces and create your own data flows depending on what you need. Okay, we have seen a couple of examples before, but think about something. It is also really common that normally the user, the customer, they have their own application already implemented, or they want to perform some kind of calculation really related to the tasks they are performing. Okay, they have something developed internally. I don't know. Normally, this kind of applications are not available, obviously, in the marketplace. Okay, and they belong to them. So how can we do that? This is not a problem. Okay, if you go back to panel, you will see we have this application library here. In the application library where you will find all the applications that are ready to be deployed to the edge node. So we have here some applications that come from the marketplace, okay, but others have this Docker tag assignment. Okay, what is that? These Docker applications are users' application, okay, applications that belong to the user, and they have upload this application by themselves. So you just need to add a new application and upload here the manifest of this application. What is the manifest? We are working basically with the Docker Compose, okay? So every application we deploy is a Docker Compose that contains different services running in different containers in the edge node. So what you should upload here is basically the Docker Compose of your application, describing the service involved with the way of the network that they use, the volume that they use. So you should work as usual when you are working with Docker, create this Docker Compose file, uploading it here. And then once you have uploaded the Docker Compose file, you can deploy the application to the edge node, okay? And the third kind of thing you can deploy using Barbara are AI model. And again, the same happens. What if I, as a customer, I have my own AI model. I've been training internally this AI model. I want to deploy them. The only thing you need to do is add your AI model, select the framework you have used to train your model and to create your model, for example, PyTorch. Then you select the engine you want to use to deploy the model in your edge node, and this way you upload the model here and you can deploy it to your user. Okay, so this is the way of deploying marketplace application, user application, and finally AI model, user AI model in the databases to create these different data flows. Okay, and then let's speak a little bit. I think we are now in the edge, how to manage the edge node. Okay, then we have the bash command and the last part. Okay, so we are on time. Let's see something about how to manage edge nodes. Okay, we have been working with edge node. In fact, let's move to this edge node, for example, we used before. As you can see here, we have our use case to calculate the OEE. Okay, but we have more information here in this part. All this information is related to the hardware itself, okay, or the device itself. So we can see here, for example, the general information, everything is organized in cars, as you can see. We can see the general information of this equipment. We can see this equipment is a virtual machine of VMware, okay? It is located in this coordinate. We can change them, by the way, okay? We can put it whatever we want. We can see the timing, and we can select the NTP server to synchronize the timing in this edge node. We can see the ID, okay? We can see also the telemetry of this equipment. By the way, we are running out of space in the disk, so we should do something to fix that, okay? We can see this information like system load or run or this. In the case, well, when we are using virtual machine, we have not the temperature, but when you are dealing with real devices, with hardware, real hardware devices, you can see also here the temperature. But then check, we can see the exact detail for every running processes, okay? We have here 6 applications, but we have 21 processes running in this equipment. And we can enter here and check all the information about the CPU consumption, or the RAM, or the file that has been opened by every process to detect failure, to detect leaks, or whatever. Okay, so everything is done in this telemetry card. Then we have the analytic card. The analytic card has the same information as the telemetry, but the telemetry gives us the last status in real time, and in the analytic we can create diagram with the evolution of every parameters. Okay, so we can enter here and say, okay, I want to see the last hour of I don't know, the CPU consumption for this process and this process and this one. Okay, I don't know, and then we select that. So this way we will see the information for these processes that you can see here. Okay. So we have the telemetry, the analytic, then we have the network card. The network card is really important because it allows us to configure everything related to the network communication of this equipment remotely, okay? So we have several parameters. We can, for example, define the host name of this equipment, okay? We can change it. We can see all the interfaces that are available for this equipment. This kind we are using a virtual machine, so there is only one interface available. It's an Ethernet interface. But if we enter, for example, in this one, which is a real equipment, we can see that now here we are having 5 different interfaces, 4 Ethernet interfaces and 1 mobile interface. Okay, we can enter in every interface and we can configure everything: IPs, add IP alias, DNS. We have the possibility of create VLANs if necessary. Okay, we can, I don't know, we have a VPN available for every edge node in Barbara that can be enabled or disabled depending on your need. If you have it enabled, you can use it to access remotely to your services, as we could see before. Okay, then we have also the possibility of use a proxy. We have the standalone mode basically to configure everything locally instead of fixing it remotely. We can also use the possibility of configure IP table to, do a fine control of the traffic, network traffic in the device. Everything is available in this network, so you can configure everything remotely. And very important, when we are dealing with network configuration, if you made a mistake and you configure something wrong, you can lose the communication with the panel. Okay. In fact, you can lose the communication with everything. Okay. So if you lose the communication, you will not be able to control the device anymore from panel. And this is something that you don't want to happen. Okay. That is why we have this parameter here, this enable rollback parameter that you can toggle. It is toggled by default. Okay. But when this parameter is enabled and you make any configuration change, the node will monitor the connection. In case after the parameter change you lose the communication, the chain will be reverted back. So you will be back to the previous value configuration and you will still have communication. So you will never be in trouble using this parameter and keeping it toggled. Okay, that is something like a security way of working when you're dealing with network. Okay, apart from that, what else we have here? We have Docker credentials. Okay, we have seen that everything we deploy in an edge node is a Docker compose file, so it contains Docker images, and you have to download the Docker images from repositories, obviously. Okay, so if you are managing with a private application, as I mentioned before, you are uploading your own application. The application normally are the application images. These Docker images are normally stored in private repositories. Okay, so you have to indicate the edge node how to access this private repository. That is why we have this Docker credential here. You can add a repository, the URL, you can add the user and the password. So this way, the edge node will use this credential to download the images from the Docker repository, and this way you can install your own application in the edge node. Okay. Apart from that, we can see the volumes. The volumes are basically the way the Docker application saves the data in the devices. Okay, so this way you can check here all the folder, not really folder, but volume. But anyway, this way of saving the data, you can check the size. You can check even if they are on use. You can check the information about what is the container that is using this volume, what is the service, what is the target. Okay, so all the information is here. And well, in case the volume is not in action, you can delete it. Okay, we can see also secret that we can define in the devices that are accessible to the application, and even configuration in JSON format that you can put it here to be accessible by application users. Okay, so well, more or less it's all the information we can see here in this card. Apart from that, you can obviously update the firmware of your edge node. Okay, you have the possibility of to reinstall or update the OS whenever it's necessary, and also to manage the life cycle of your equipment. Okay, we have the normal option, reboot, shut down, which should be handled carefully, because if you shut down an equipment, then you have to put it on again manually, and this is something you don't want to happen. You can deactivate the equipment, you can delete it from the Barbara panel, you can remove it from there. And then we have this wipe and break option, which is like a security option in case you think that somebody could have stolen your device. Okay, in that situation, so somebody has access, physical access to the device, you can send this command that when the node receives this command, it will delete absolutely everything that is available in the disk and the edge node, even if all the data is encrypted. This command will break your device, will delete everything. So in case they have access to the disk, they will not find any information about your data. Okay. Okay, we have only 10 more minutes and we are going to see the two final functionalities very quickly. Okay, but at the end, what we will see is how to, well, we have seen a little bit about how to manage group of edge devices in parallel, okay? Normally we have a lot of head devices deployed. Here we have 18, okay? How can we manage them? This is a normal way of doing that is we can create groups, okay, as you can see here, okay, we have several groups containing different equipment, okay, so we can use this group to select only some devices and then we can command these devices on parallel, but we can do the same with all my devices, okay, so I can select all my devices, okay, and when I have selected all of them, I can use this button here to do any command that is available for a single action or is also available for a group of them. So I can activate or reboot or deactivate or change the parameter, change the networking, install any Docker application, install any marketplace application, everything, updating the firmware, everything is available to a group of them. Even if some of them, as you can see here, some of them are offline, okay? It is not a problem. We will send the command to all of them, and as soon as this device gets connectivity again, they will apply the command, so they will be at the same status, all of them, okay? So it is a very easy and powerful way of commanding big fleet of edge nodes all at one with a single click, okay? Well, finally, we are going to explain one of our latest functionalities, which is this one, high availability, okay? I will move to panel to do that. Okay, we have here this cluster section that we had not mentioned before. Okay, we have been working with this node section, and now we are going to move to this one, which is clusters, okay? In the industrial world, in the industrial environment, it's very common that the customer wants their services to be running without interruption. Okay, obviously, they want to have services in high availability. That means that no matter what happens, my services should be running 100% of the time. Okay, if we want to guarantee that, we cannot rely on a single edge node by obvious reason. But imagine you have an edge node with a node-RED calculating some parameter, reading some parameter using OPC UA or whatever, and the hardware that we have in this edge node have any problem, or we have a power supply problem, or no, I don't know, something like that. Okay, in that case, obviously, your edge node will go down and the service will stop running. Okay, and we don't want that to happen. Okay, that is why we use this cluster functionality we have here. Okay, what is the cluster? The cluster is a way of creating groups of nodes that can work together. Okay, so for example, here I have created one ignition, so sorry, one cluster. This is the name. Somebody has named it cluster ignition, so we can call it just cluster. Okay, anyway. And it is basically composed by 3 different edge nodes, node 1, node 2, and node 3, okay, as you can see. And here, what we see is that we have a application, in this case, it's an ignition instant, okay? So in the same way, before we were deploying application on top of an edge node, here, what we are using is create a cluster composed by different edge nodes and putting the application on top of the group. So in case any of these equipment have any problem, okay, for example, here check that the application is running on this equipment, okay, this ignition 01, okay. This means that this number 1 in purple means that the ignition is running here in this edge node, okay. What we can do is, for example, say, imagine I want to, I don't know, update the firmware of this device. If I update the firmware of this device, the device will reboot. And during the reboot time, the service will go down, obviously, okay? So what can I do? What can I do is saying, okay, since I am going to reboot, to update this equipment, I will drain it, okay? I have several possibilities here, but one of these things is drain the edge node. Draining the edge node means leaving it empty, okay, saying the application, okay, move to other equipment, okay, because I am going to pause to be updated, okay, so I can drain the node, okay, So it will transfer all the tasks, applications, and model, and even the data, okay, will be transferred to other available modes. So I will press drain, and this way, in some second, this application will be moved to either this one or this one. I don't know, either one of them. It will take some second to be changed. Here we have it, okay? So now the application has moved to this ignition 03, and it will disappear from here in some second, okay? So this is the way of working when you are using a cluster. In case the node disappears, the system will move the application automatically to the other available equipment. But even we can do it manually in case we want to use the device for something or whatever. We can move the application from one device to the other. But anyway, the application and the service is always running with high availability 100% of the time. This is a very, very powerful functionality because I can select whenever I add any application. Okay, for example, I don't know, I'm going to select, let's select ignition, for example, the same one that we have. Okay, I have the possibility of, configure everything like we did before, selecting the ports and including the JSON or whatever, but then I have more steps because now here I can indicate how I want to deploy the application. If I want to use in a global deployment mode, in this global mode, there will be an instance of the application per every edge node, or if I want to select, I want just one replica or two replicas of the application to select how many instances of the application will be installed in the edge node, and then I can select all the devices in the cluster have some tags. Okay, so I can select the tags that I want to use or create even new tags. Okay, so I can see here what are the tags that are available in this edge node. So I can say, okay, I want to use this tag, so the application will be installed in the edge node that contains this tag instead of other. Okay, so it is a really, really good and powerful application, and this is also available in the Barbara platform. So I think that is this is quite a lot of information, Miriam. I think we have covered everything, but yes, I think that's a good time for leaving the floor to our guest to check if there is some more question today.
Okay, there is another question regarding the latest features. Is it possible to make a backup of an entire node in case we need to reinstall it? And will it be possible to download a set of applications running in a node to another node? Let's suppose they are similar and I want to use the applications, only make small adjustments.
Okay, the possibility to make a clone, let's say, or a backup of the national node is available. It is available again using the API. Okay, we are working on the UI interface, but it's not ready at this moment. It's also in the backlog. But using the API, you can create a backup of all the applications that are running in an edge node. Not only the application, also the volumes where the data of that application is running. Okay, so we can create a backup of everything, and then we can install it in a single click in another edge node. So it's possible to be done. Okay, no problem about that.
And do all nodes need to have identical hardware when creating clusters?
No, not really, not really. In the case I mentioned, there was all virtual machine. They were the same, but it's not necessary. So we can create edge node with different kind of hardware. Okay, that is why, in fact, we have these tags, this labeling. For example, imagine I have a cluster with 3 edge nodes. Only one of them has a GPU available. Okay, and the other 2 edge nodes are normal with CPU only. Okay, so I can tag the GPU node with the label tag and with the label GPU. So when I am deploying the application on top of the cluster, I can select, I want to deploy the AI model only in the node that has the GPU. Okay, so we can create cluster with different hardware. Okay, and then we can select how to use them in case we need to do that. Okay, but it is not at the end. The short answer is not. We can use different hardware to create clusters.
Good. I don't see any more questions. It's already 4:30. Well, thank you, Enrique, for the great presentation, and thanks to all for joining us today. We will be back in January with new updates and another tech dive, so please stay tuned. And I kindly ask you to fill in the short survey we're just going to launch after the webinar. So thanks again. And goodbye. Bye now. Bye-bye.
Thank you, everybody, for your time.
Thank you.
Bye-bye.
Take care. Bye-bye.